In this video, we are going to do 17.02 compatible liters. All right, so I have it downloaded and opened up in Racket. So let's just read through the problem statement over here. So, problem A, design a function compat-blood that consumes a recipient and donor blood types and produces whether the recipient is compatible with the donor's blood given the following constraints. And here are all the following constraints. So I welcome you guys to pause the video right now and read through the following constraints. I'm going to go over them as I go over the solution to save on time, all right? It can also be explained by this chart over here, all right? So I'm going to copy and paste the link to this chart and explain this problem through this. All right, so we're going to work row by row and then column by column, right? So if my blood type is B negative, right, I'm going to go to the B negative row and then look at where the blood droplets are filled in. And then that is what I can receive, right? So if I'm B negative, I can receive O negative and B negative. If I'm O negative, I can only receive O negative. And if I'm, AB negative, I can receive O negative, A negative, B negative, and AB negative. And these two over here are the special types of blood. So type AB positive is the universal recipient. So we can look at the AB positive row and see that's all filled in, right? So the AB positive, you can take in anyone's blood, all right? Likewise, type O negative is the universal donor. So if we go to the O negative column, we're going to see that O negative can give blood to everyone because everyone is compatible with O negative, right? They can take it in. All right. So note that the data design example/test has been done for you in this problem. All right. So we scroll down here, the data design is this blood type. It's these sets of strings of all the blood types. And here are all the tests, right? So O positive can only receive blood from itself or O negative, right? So this is receiving blood from itself. O positive and O positive produces true. O positive and O negative produces true. Everything else, every other combination produces false. And you can read through all these tests if you'd like, but for the sake of time, I'm going to skip through them and scroll down to the starting of the problem, right? The starter code here. So we have a signature compat-blood. It consumes two blood types and produces a boolean. Produces true if the first given blood type is compatible with the second given blood type. And that second given blood type is the donor, all right? To do, code up compatible blood, all right? So pause the video and try to work through this on your own. Hopefully everything up here, the tests, the signature, the type comments, etc., should give you a good hint and good mental scaffolding to solve compatible blood. I'm going over spoilers. 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. All right, so what I'm going to do is I'm going to close this. I'm going to minimize it and put it up here in the top right corner because we're going to need to look at it. All right. All right, so hopefully everyone can see this. Okay, so we're going to work row by row. So we're going to look at AB positive. So here's AB positive. And it can consume, right? It can receive everyone's blood, right? So we could do, or string equal donor, and then is that O positive, O negative, etc. But since everyone, right? Since AB positive can receive everyone's blood type, we can just produce true, right? It doesn't matter who the donor is because, you can receive anyone's blood, right? So we don't really have to check. What about the next blood type? AB negative. Let's look at the AB negative row, and we see that it's compatible with O negative, so it can receive O negative. So we have to make sure the donor is O negative, and then we have to make sure that it's compatible with all the other ones too. So I'm going to copy and paste it 4 times. 1, 2, 3, 4. All right, so O negative, A negative. That's another one that we're compatible with. Next one is B negative. And then the last one is AB negative. All right. So the donor has to be one of these, right, to be compatible with AB negative. Let's do the next one. A positive, right? So I'm just going to copy this down because it's roughly the same and just change things around. All right. So if I'm A positive, right, I can receive O positive. So O positive. See, O negative. O negative. What else? A positive and A negative. A positive and A negative. All right, let's move on to A negative. if I'm A negative, what do the donors have to be, right? Here's A negative. Well, they can only be O negative and A negative, right? So this is this right here. Gonna just wrap this around an OR. So the donors have to be O negative or A negative. Let's move on to B positive. B positive, right? I can receive O positive, O negative, B positive, and B negative. All right, so I'm just going to copy this here. All right, so I can receive O positive, O negative, and then B positive, and B negative. All right, let's move on to the B negative case. B negative. If I'm B negative, I can only receive O negative and B negative. All right, so I'm just going to copy and paste. If the donor is O negative, or if the donor is B negative, then that is compatible with us being B negative. All right, gotta wrap this around an OR. Let's move on to the next case, right? O positive. O positive is only compatible with O positive and O negative, right? So O positive and O negative, like so. Wrap this around the OR. That's what our donors have to be. And the last case, O negative. O negative. All right. So O negative is only compatible with O negative. It's kind of sad, to be honest, but nonetheless, string equal ha, the donor has to be O negative. All right, so that seems like all the branches done. So let's just run it against all our tests and see if it passes. And as you can see, I'm gonna maximize this back out. We see that all 65 tests do pass. All right, so now the final step is to test, review, and refactor. So it passed all our tests, so that's good. It looks fine aesthetically, but we can remove a bunch of cases and simplify this code to be a lot shorter, right? And that lies in the problem statement. So what I'm gonna do is I'm gonna comment this out and copy and paste it all the way above here, right next to the problem statement, because that gives us a hint as to how we can simplify it, all right? So this, if you cut up these branches and eliminate some checks, you can simplify this, all right? Simplify compat-blood, compat-blood, all right? So pause the video and try to work through the simplification of compat-blood, Remove our spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So if we look at these constraints over here, a recipient can receive blood from anyone with the same blood type, right? So if you look at the chart over here, right, if I'm B negative, I can receive B negative. If I'm A negative, I can receive A negative. If I'm A positive, I can receive A positive. If I'm AB negative, then I can receive AB negative, etc., 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 right? So if any blood can receive its own type, right? So we can just cut up that branch up here, right? So string equal all right? If we and the donor have the same blood type, can just produce true, right? And we can just eliminate all the checks, right? So this is AB negative, right? AB negative, this branch is checking if the donor is AB negative, but we just push that branch all the way up here, right? So therefore, this branch will sort of like run first, right? It's going to run through the execution of this code. It's going to hit this branch first, and it's not even going to hit this AB negative case, right? When the donor and the blood is AB negative, when they're the same, right? So we don't really need this check right over there, right? When they're the same. Likewise, for A positive, right? If I'm A positive, the donor has to be A positive, right? We just push that branch to here, right? So like so, we can delete that check. In fact, I'm just going to comment this, right? Same blood type as me. All right. So this one, A negative, checks that the donor is A negative. That's fine. We push it up here to same blood type as me. This checks if we are B positive, and this checks if the donor is B positive. We pushed up that branch. Same with this here, B negative, and O positive, and this last case over there, right? All right, so let's move on to the next one. A person with O negative blood can be a donor for anyone, but can only receive its own type, right? So O negative blood, right? It can give blood to everyone, but it can only receive its own type, right? So since this function only deals with if the donor is compatible with us, right? We can just cut up that case as well, right? So string equal ha, if the donor is O negative, just produce true, right? Like so. So that is that case done. We can remove all the checks then check if the donor is O negative because we pushed it up to this branch, right? So this is the universal donor, all right? All right. So you can just delete all these O negative checks, like so. So O negative check, checking if the donor is O negative. Okay, and last one. All right. So the next one is a person with AB positive blood can receive blood from anyone, right? So it's this case here, right? If I'm AB positive, just produce true, because if you're AB positive, you can just take anyone's blood type, right? Just grab a blood bag off the shelf. It doesn't really matter. So we just produce true there. All right. Now we can see that we have some empty branches here, right? So it means that doesn't really matter anymore. We can delete those branches. So I'm going to do that a little later. But let's check these 3 branches, right? Because there are these 3 cases left. So AB negative blood can receive blood from a donor with B negative or A negative blood. So here's AB negative. It can receive a donor that's B negative or A negative. So that's this done. Let's move on to A positive, right? A positive can receive blood from a donor with O positive or A negative. Right, so here's A positive. It can receive blood that's from O positive and A negative. And I forgot to remove this O negative check, right? Because we pushed it up to the universal donor branch up here. So I'm just going to delete that. Likewise. All right. This other case, a person with B positive blood can receive blood from a donor with O positive or B negative, right? So here's our B positive, right? It can receive O positive or B negative. No other combination of donor and recipient blood types is compatible, right? So we can just delete all these branches. So this and this. Right, let me see if I'm doing that right, actually. Yeah, okay, they're all pretty empty in this. But you have to be careful, right? It says, no other combination of donor and recipient blood types is compatible, right? So that just highly indicates an else, right? So we're going to need an else here. Else false, because false means that it's not compatible, right? So that's that last branch. So if we just run this simplified version against all our tests, remember I commented out the expanded version below, it passes all our tests the exact same, right? So the exact same functionality, just shorter code, and it's just a different way to implement it. So I'm going to paste it down here, and you can see it side by side as to how much shorter it is. And that comes from the problem statement itself. Okay, so yeah, let's move on to the next problem, problem B. So problem B says write a function compatible-liters that consumes a list of blood type and adds 1 liter per blood type in the list that is compatible with the given blood type, right? Use compat-blood in your solution. So that's the function that we just wrote earlier. So for example, compatible-liters of the list A negative and O negative, and our blood type is AB negative, should spit out the number 2. Why? Because AB negative is compatible with O negative, right? So here's our AB negative, right? It's compatible with O negative, so that's 1 blood type that we're compatible with. And there's also A negative in this list, A negative. So that's another blood type that we're compatible with, and we produce 2. So basically, right, this is us, and this is the amount of blood types, the list of blood types. And we're just counting up how many blood types are compatible with us, right? So B negative, right? So if I'm B negative and there's a list of blood types that's A negative and O negative, right? Well, B negative, I'm compatible with O negative, so I'm going to add 1. But am I compatible with A negative, right? Is B negative compatible with A negative? No, right? This is not filled in. Therefore, we just produce 1, all right? So hopefully that gives you a better idea of compatible-liters. All right, so we see the data design here, list of blood types is one of either empty, cons, blood type, list of blood type. So this is a recursive structure, and we see the recursive template here for the function. All right, so here's the signature for compatible-liters. It consumes a list of blood type and a blood type and produces a number. Produces the number of liters that are compatible with the given blood type in the given list. To do examples and code compatible-liters. All right, so pause the video and try to work through coding up compatible-liters, the examples, and then the code of compatible-liters on your own. I'm going to go over spoilers in 3, 2 and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So we see that this has produced a number. So let's just use 0 as our stop value. And let's write some tests. So check expect. I'm going to do compatible liters. All right, like so. All right, so compatible liters empty. And then let's say our blood type is A positive. All right, what should this produce? 0, because there's nothing in the list of blood types that is compatible with A positive. In fact, there's nothing in this list of blood types at all. It's just an empty list. All right, let's move on to the next example. Check expect. Say compatible liters of, let's say, cons A positive empty, and then our blood type is still A positive. What should this produce? 1, because A positive is compatible with itself, right? Like so. All right, so I'm going to copy and paste this down below. Let's change this A positive into a B negative, right? Is A positive compatible with B negative, right? The list that contains B negative, the list of blood types. No, right? So we go to A positive, right over here. It's not compatible with B negative, right? So this should produce 0. And likewise, you can take the test here, up here. So we're going to copy and paste it. So this one is checking if check expect compatible liters of O negative, AB negative onto the list O negative and A negative. Well, both of them are compatible with AB negative, so that should produce 2. And likewise, this one, let's test over here, like so. Check expect. This should produce 1 because only O negative is compatible with B negative, right? We're B negative. And only O negative is compatible with it, so we just produce 1. A negative is not. Let's do one more test for fun, right? We're going to do check, expect, compatible liters, right? This time let's pass in every blood type. So this list, right? This example for the data type, right, is every blood type. So list every single blood type there is. Right, let's find the universal donor. So universal donor, universal recipient. Let's do the universal recipient. Let's say we're AB positive. If we are AB positive, right? AB positive, right? How many are compatible with AB positive, right? Well, all of them, right? So 1, 2, 3, 4, 5, 6, 7, 8. So this should produce 8. All right. So let's run our stub against our examples here. And it looks like we just get some not defined. So I must have spelled compatible wrong. So I'm just going to copy and paste it like so. All right. And I'm going to run it. And it looks like it's just mismatches now. Okie dokie. I'm going to come out the stub, grab something, a template that consumes a list of blood type, and use that as a scaffold. All right. And rename the function like so. So compatible liters takes in 2 arguments, the list of blood type and a blood type. So the list of blood type is going to be stored in the variable called bank. And we'll say the second one is B type. All right, so now really pause the video. Hopefully this should be all the mental scaffolding needed to solve compatible liters. Remember, you have to use compat-blood in your solution. All right, so pause the video and try to work through the solution on your own. I'm going to go with spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So the first branch here, right? If we consume an empty list, we just produce 0 because nothing in that empty list is compatible with our given blood type, right? So produce 0 liters. Now comes the harder part, right? So for this one, we can see that sometimes we count up the amount of blood types that are compatible with us, and sometimes the blood types in the list are not compatible with us, right? So sometimes is, sometimes not, right? So for this B negative case, right? O negative is compatible with B negative, but A negative is not, right? So again, sometimes it's compatible, sometimes it's not. Looks like it's some decision making that's going on here. So we need an if. All right, so if, and then what? Well, we need to compare the blood types, right? So this needs to be wrapped around a compat-blood, and we need to pass in first the blood type that's us, and then the donor, right? So this is us. That's going to be the first parameter of compat-blood, and then the list right? The first of every item in the list of blood type is the donor, right? And you can check compat-blood and you'll see the order of the arguments here. It's kind of important, right? Blood is us and the second argument is donor, right? So we want to make sure that matches there. All right, so if has 3 parts. So that's the first part. This is going to be the second part and then some third part. So what do we want to do when it is compatible, right? When our blood types are compatible? Well, we want to add 1, right? Because we want to count up the number of blood types that are compatible in this list. All right, so that's adding 1 here, right? This will mostly pass these 2 tests. Gets us most of the way there, but we still have to look through the rest of the list, right? Because we're dealing with a list of blood types, right? So there can be a ton of other blood types left. So we want to add 1 to the recursive call to compatible-liters, right? Onto the rest of the list, right? So keep looking through the rest of the list to make sure that there are other blood types, to find other blood types that we're compatible with. All right, likewise, this compatible-liters takes in 2 arguments, right? So compatible-liters takes in a list of blood type and a blood type. So we have to actually pass in our B type here. All right, because it comes along for the ride. All right, so that's the true branch. What about the false branch, right? Well, in the false branch case, right, we just keep looking through the rest of the list without adding 1, right? So for this B negative case, right, for A negative, it's not compatible with B negative. So we don't want to add 1. We just want to continue looking through O negative and then the rest of the list if there are any. In this case, there's an O negative. And since that's going to be compatible with B negative, right, it's going to be compatible. We're going to add 1 and it will produce 1 here, right? So yeah, we're pretty good. So let's just run this code and compatible-liters expects 2 arguments, but only found 1. Oh, I forgot to pass in the blood type here. Right, compatible-liters again takes 2 arguments, the list of blood type and then the blood type. So we just have to pass this along. And likewise, all 71 tests pass. All right. So likewise, you can simplify this compatible-liters. I mentioned that if you have a nested if, right, a con with if statements, you can put this out into the branch of cons. So these 2 are exactly the same, just a different way of writing it. Remove that if, and if I comment out the one above and run the one on the bottom, all the tests pass the exact same. It's just a different stylistic way, whichever one you prefer. All right, so I'm just going to leave it like this, and I recommend you guys submit it to Hand-In and pass the grader tests. All right, and that is about it for this video, and I will catch you in the next one.